I'm probably going to gloss over a lot of the explanation here because most of y'all have already finished your economics courses and you at least have some idea of what elasticity of demand is. So basically, if you sell a product or a service, you want to keep in mind how the price changes will affect demand. What causes what? Sensitivity of demand to that change in price, it depends on kind of like what kind of items you're looking at. Are they luxury things people can do without? Or are they things people have to have, and it doesn't really matter what you charge for them? You know, it'll influence it some if you try price gouging, but there's probably, since everybody buys it, you've got competition that keeps you in line and you don't try to jack up your prices. Unfortunately, I don't think the oil companies understand that. But, for example, a car, a home loan, jewelry, concert tickets, a small change in the price is likely to decrease the demand. It's like, oh, well, I don't really have to buy that new car now. I'll wait until they put it on sale in October or whenever, okay? Or for concert tickets, well, you know, that's a pretty high price for a concert. I'll wait and go to this concert over here. I don't want to have to pay that much money to go to that one. But now, if it's stuff like light bulbs and gas and groceries, man, you got to eat. You know, you have to drive your car. Hopefully you need a light in your house. So small changes there will not really change the demand appreciably. It will change it a little bit. You know, you might not buy as many of something, or, you know, if you're buying, you may change the store that you're buying it from rather than just not buy it. So there's a lot of ways that elasticity of demand does affect business. And as consumers, we need to understand that too. So one of the ways that you measure the sensitivity of demand to changes in price is by the relative change, or the ratio of percentage change in demand to the percentage change in price. If Q represents the quantity and P is the price, you know that P is a function of Q. The price is going to change based on how many are demanded. So the formula, the ratio we're looking at, can be written as the change in Q over Q divided by the change in P over P. That ratio is always negative, always. And the reason it's always negative is because the change in Q and the change in P are going to have opposite signs. An increase in price will cause a decrease in demand, okay? If the absolute value of that ratio is large, then it actually suggests that a small increase in price causes a relatively large drop or decrease in demand. So we're going to use that to actually come up with a formula to calculate the elasticity of demand. And I'm not going to hold you accountable for all of this. What I'm going to do, this is an explanation of how the calculus plays into it. Remember, this is actually kind of like a slope formula. This actually is a slope formula, and this probably looks familiar to you because back in Chapter 11, we actually did difference quotients. And that's what this is a difference quotient. And as the change in P here becomes close to 0, then this value, as the change in P approaches 0, turns out to be just the derivative of Q over the derivative of P, or dQ over dP. That's where the formula comes from. So here's our formula. And it's the negative of that because, remember, that ratio is always negative. So in order to find the elasticity of demand, where Q is the demand at a price P, the elasticity of demand is E, is negative P over Q, times the derivative of Q with respect to P. okay? The derivative of Q with respect to P is the way that's read. This will come out to be a number that's less than 1 if demand is inelastic. If it comes out to be greater than 1, then that means demand is elastic. There is what we call unit elasticity if E actually turns out to be equal to 1. Okay? So you keep that formula handy as you work problems. And this is an example of how you would actually calculate. So I'm going to hang on to the formula sheet up here. E has been estimated to be 0.6 for physician services and 2.3 for restaurant meals. If you're sick, you have to go to the doctor. If you're going to eat dinner, you don't have to go to a restaurant. You can go home, or you can go to a cheaper restaurant. So the relative change in demand is less than the relative change in price. That's what we call inelastic. So that's why physician services are inelastic. Demand is inelastic for things that people have to have. It is elastic for things that they don't have to have. It's greater than 1. Unit elasticity means that basically if you raise one, the ratio of change in the other is the same. Basically, the percentage changes in price and demand are going to be pretty much equal. So that they'll kind of cancel each other out. And that's when you have unit elasticity. So here's our first example. Terence Wales describes the elasticity of demand for distilled spirits as Q is equal to F of P, which is negative 0.00375P plus 7.87. He would have arrived at that by studying demand values for spirits, for distilled spirits, over the course of a period of time and at different prices. So what everything represents here, P is the retail price of a case of liquor, and Q represents the average number of cases purchased a year by a consumer. We're going to calculate and interpret the elasticity of demand when the price is $118.30 per case. Okay? Now, before we even begin the problem, let's think about this. What do you think is going to happen to the elasticity of demand for liquor? Which category should it fall into? Elastic or inelastic? Elastic, because you don't have to have it. You could do without. Okay? Okay, so what we're going to do first, remember that E, this is our formula, E is equal to the opposite of P over Q times dQ dP, which is the derivative of Q with respect to P. Okay? So it's the derivative of this. So the opposite of P over Q, well, that's not too bad. This part, without plugging in the number, this part is P over the expression for Q. And remember, this whole quantity is negative. Okay? And then we need to multiply it by the derivative of Q. And since Q is a linear function, its derivative is going to be a constant. So the derivative of this is going to be negative 0.00375, and the derivative of that is 0, so we don't have to worry about that. It disappears. And there's your formula for elasticity. And elasticity doesn't have units, so you don't have to worry about, me underlining with units, because it doesn't have it. Okay? But it does have an interpretation. It does have an interpretation, and we do have to have that. So this whole expression actually simplifies. E is equal to negative times negative becomes positive 0.00375 times P over negative 0.00375 P plus 7.87. So there's the formula for the elasticity at any price. Okay, this is for any price. But we have a specific price. We were given a specific price. What is the elasticity when P is equal to $118.30? So in order to answer that question, we plug in $118.30 for P. Question? Or did I mess up? Because the original demand equation is negative. This it does at the end, yes. Okay, this is the formula, okay? Let me make sure you understand where all the negatives are coming from. This negative sign is coming from the formula, right there, okay? This negative sign is coming from the fact that that's what Q equals, okay? It includes that negative sign right there. And then this negative sign here actually comes from the same place because it's the derivative of Q, okay? So then when I actually multiplied everything out, negative times negative would make that positive, but this is still negative, and I left the negative down here. You don't have to leave it down there. You can actually put it up here, but I left it down there. No, I see where you're asking me about now, though. That is not negative. That is not negative, sorry. I forgot that I had already removed the negative sign, so I'm glad you caught that. So now we need to do some arithmetic, and of course, you're doing the arithmetic, you're going to do it on the calculator. And it turns out, if you evaluate that function on the calculator, it turns out to be about 0.597, which is less than 1. Okay, that's less than 1. That means demand is inelastic because it's less than 1. And what that means is that a small change in the price at that point will create a large drop in demand. If they boost the price, demand's going to go down substantially. Even though it's only a small price increase, it will have a definite impact on your demand. It will cause it to decrease a lot. It's inelastic. Okay. So if they jack the price up, you say, okay, I'm not buying it. That's just something I can cut out. I'll buy less of it. Okay? Does anybody have any questions? And I'm trying to keep these in order. Don't fight over them at the end of class. Okay. Our next example, the demand for beer was modeled by Hogarty and Elzinga for the function given by Q equals F of P, which is 1 over the price. So the quantity is basically inversely related to the price, is what that's saying. The price was expressed in dollars per can of beer, and the quantity sold in cans per day per adult. They want us to calculate and interpret the elasticity of demand. Okay? Now here again, we're talking about beer. What do you expect the elasticity to be? Inelastic? Because that's what you think it's going to be elastic. How's beer different from? Yeah, it's going to be the same as last time. Okay? Okay. So we think it's probably going to be inelastic because of the commodity we're talking about. So we do the formula, and again, the formula E is the opposite of price over quantity times the derivative of quantity. So we start off with a negative sign. And we're going to have two different pieces. The first one says take price, which is P, over the quantity formula, which is 1 over P. And this part says take the derivative with respect to P of the function 1 over P. So I'm trying to do the explanation in slow steps. So when we do that, this is what we get. In that first set of parentheses, P times 1 over P, or excuse me, P divided by 1 over P is actually more easily understood to be P times P over 1, because dividing by 1 over P is the same as multiplying by its reciprocal, P over 1. Okay? So that means this part of the equation is actually going to be P times P, which is P squared. So that's negative P squared. The derivative of 1 over P is more easily taken if you consider that that's P to the negative 1 power. So the derivative of P to the negative 1 power is negative 1 times P to the negative 2 power. So then we'll multiply through or combine that to get the formula for elasticity. So let's see, this is actually negative 1 over P squared. So if I take negative P squared over 1 and I multiply it times negative 1 over P squared, what happens to the P squareds? They cancel each other out. So I have basically negative 1 over negative 1, which is equal to 1. So even though it's kind of counterintuitive to us, the elasticity here is unit elasticity. And that means demand will be constant regardless of changes in price. The demand's not going to change. Now that is kind of counterintuitive because you think, well, beer is, it's like liquor, is you don't have to have it. But the difference is the liquor costs a lot more to begin with. The beer doesn't cost as much. So as long as the price doesn't go through the roof, you know, and somebody charging $5 a can for beers, you know, I'd say that would change things considerably. But, you know, for relatively small changes in the price, the demand's not going to change much. Remember, this is all based on small changes in the price, not huge changes, small changes in the price. Okay? So small changes in a small price could be unit elasticity. The next one we've got is elasticity, and I'm talking about total revenue. You know that your revenue equation is R is equal to P times Q. We've seen that time after time after time. We've had to suffer through algebraic practice trying to figure out what the revenue equation was, depending on how the P and Q information was given to us. But you can actually calculate the elasticity of revenue just using your revenue formula. If you take the derivative of your revenue formula with respect to P, then the derivative of revenue with respect to P is P times the derivative of Q plus Q times the derivative of P, which is 1. And what we're going to do then is we're going to multiply all the way through this equation by Q over Q. Q over Q is equal to 1. This is just some algebra magic. So we're multiplying by Q over Q. Q over Q equals 1. So multiplying through by that doesn't change anything. Okay? We've just introduced a factor of 1. But when we do that, notice what happens is that Q kind of cancels out the 1 in the bottom. And what is this the formula for? That's the formula for elasticity. Okay? Only thing is, this is positive, but we know elasticity is negative, so we put in a negative in front of the elasticity part of it. And that's because E is equal to negative P over Q, dQ, dP, and since we have this, then we need to put the negative over there with the E. And now if you factor out a Q, then you have Q is equal to 1 minus the elasticity. Now, that doesn't seem very impressive if you just sit there and look at it and say, okay, so what? Okay? But here's the point. Here's the point in English. Now, what is the fact that this value of elasticity, depending on whether it's elastic, inelastic, or whatever, your total revenue is increasing optimized or decreasing depending on whether dr over dq is greater than 0, which means it's increasing. Equal to 0, which means it's optimized, because that means your derivative is 0, and 0 always tells you you've got a relative maximum or a relative minimum, but in this case it's going to be a maximum. Or, third possibility, that derivative is negative, which means then your total revenue is decreasing. This is dr dq. Actually, that should be a small d. That's the formula for dr dq. That is, in fact, always the formula for dr dq. Okay? That's an important point. So in the plain English, if demand is inelastic, total revenue increases. Total revenue increases as your price increases. If your demand is elastic, then your total revenue decreases as the price increases because people aren't buying it. You're charging too much. But the really good part about this, the wonderful part that we learn out of this, is that you can figure out where your revenue is optimized based on elasticity. Your total revenue is maximized when E is equal to 1. So that's very important. Because if E is equal to 1, then you have this is 1 minus 1, and that's 0. The value of the derivative is 0, which means your demand is not increasing or decreasing either one. You have maximized your revenue. The same thing would work with other functions, but revenue is the one that we usually look at because that's the thing that's most commonly associated with demand, with supply and demand. And that's just a graphic so that you understand what's happening. This is where you have your dr dq is equal to 0. On this side, your demand is increasing. I'm sorry, I think I said that backwards. Here, your rate of change in revenue is increasing. And that's from inelastic demand. And on the other side, your demand is elastic, which means your revenue will be decreasing for small changes. So picturing that curve might make it easier to remember what's going on with the elasticity. Okay? So we're going to do one example of that. So we're going to assume that the demand for a product is equal to Q, and the formula or the function for Q is 216 minus 2Q squared. I'm sorry, 2P squared, not Q squared, 2P squared, because quantity is a function of price. And P is the price in dollars. We want to find the price intervals, and this actually kind of goes back into what we did in Chapter 13. We want to find the price intervals where the demand is elastic and where is it inelastic. Okay? So the first thing that we need to do is we need to calculate E. So the price is P. And the quantity is 216 minus 2P squared. And then times the derivative of Q, and the derivative of Q is 0 minus 4P. Everybody good so far? And then we want to kind of multiply that together, so you remember that this is just by putting it over a 1, so that negative 4p goes with the p in the numerator. And since this is negative, and this is negative, then our formula for E is not going to be a negative, it's going to be positive. P times 4p is 4p squared over the denominator, 216 minus 2p squared. So there's your formula for elasticity. So basically we need to know where is their unit elasticity, because that's where your where it's going to be optimized. Your revenue stream is going to be optimized. You're having a maximum value. Okay? So instead of setting it equal to 0, because we want to find out where the unit elasticity is, because that's where the derivative is equal to 0, what we're going to do is we're going to set this equal to 1. Okay, so it's because E equals 1. We're actually finding out where the derivative is equal to 0. And that's when E is equal to 1. So we've got this function here, 4p squared over 216, oops, not p, 216 minus 2p squared. We're going to set that equal to 1, and just to make it easier to solve, we're going to do 1 over 1. And if we cross multiply, that means that 1 times 4p squared is 4p squared, is equal to 1 times this is equal to 216 minus 2p squared. And you didn't actually have to do that part. You could have looked at that and said, well, you know what, this is only going to be equal to 1 if the numerator is equal to the denominator. So you could actually shortcut that whole step just by knowing that if that ratio was 1, then these two things must be equal to each other. And then we need to figure out what P is going to be. So in order to do that, we're going to add 2P to both sides. I'm sorry, 2P squared. And 2p squared plus 4p squared is 6p squared, is equal to 216. And then we're going to divide through by 6. And p squared is equal to 216 over 6. And I'm not going to change that down right now because, well, actually you can, because I think that goes evenly. Let's see. Yeah, it's 36. If it hadn't come out to be something fairly easy to figure out, I'd have just left it as a fraction and dealt with it at the end. Because what we're going to have to do now is we're going to have to take the square root. So we take the square root of both sides, and p is equal to the square root of 36, and obviously you want the positive answer, because price is not negative. So it has unit elasticity at $6, at a price of $6. Okay? That's what we just found out by knowing that. That means in order to figure out where it's inelastic and elastic, then we're going to test on both sides of $6. So I'm going to let you choose. Pick me a number that's less than $6 and a number that's more than $6. 5 and 7. Easy enough to do. So, I think I need, I'm going to need another piece of paper. Still somebody's sign stuff. Of course, 0 is going to be on that one end. We really don't go on forever on that end. So here's $6. Here's $5. Here's $7. So if we let P equal 5, then we're going to plug that into our formula here. And you do the math and tell me what it comes out to be. And then the same with 7. This should turn out to be less than 1. This one should turn out to be greater than 1. Does it? Okay. So it's not really the value itself that we're worried about. Is the ratio less than 1 or is it greater than 1? Is the fraction a proper fraction or is it an improper fraction where the numerator is larger than the denominator? And that's actually not hard to see because 5 squared is 25. And 4 times 25 is 100. And 5 squared is 25 times 2 is 50. 216 minus 50 is 156, 66. And that is a ratio that is less than 1. Okay? Whereas here, 7 squared is 49. And 4 times 49 would be 196, maybe? 396, oh, yeah, thank you. And then 2 times 49 is 98, so 216 minus 98 would be 118, am I right? So 396 over 118 would be a fraction that's greater than 1. Okay? What? Okay. Still bigger. That's the only thing that matters is that it's bigger. Okay? Remember, this is 49 and 4 times 49. 2 times 49 would be 98, and then another 98 would be the 196. Yes?
So you have to do the elastic equation, and once you multiply the theoretic times the derivative, have to set equal to 1 every time?
You'll always set it equal to 1. You just set it equal to 1. And remember, the reason you set it equal to 1 is because that's where the derivative of it was 0. When the derivative is 0 is when the demand is maximized. Because remember what happens, let's go back to the picture for a second. Remember what happens when the elasticity is equal to 1, what happened was that the derivative of the revenue with respect to price was equal to 0. There, that 0 is where you use it as critical value. Okay, that's the derivative is equal to 0. That gives you a critical value. But since we're talking about elasticity, that derivative is equal to 0 when your elasticity is equal to 1. Okay? Those are you need to tie those two together. So once you find out where your revenue is maximized, which is when its derivative is 0 or elasticity is 1, then on one side of that your demand is going to be inelastic, and on the other side it's going to be elastic. Okay? Now, as for which way it is, you're going to have to actually test numbers in both intervals, just like we did in Chapter 13, to see when we get an elasticity that's less than 1 and when we get an elasticity that's more than 1. Okay? So that means what we've discovered here is that the demand is inelastic for less than when the price is less than 6, and elastic when P is greater than 6. That's the actual interpretation of the problem. And then our last question is, assume that the demand for the product is the one we just looked at, and P is the price in dollars. What price gives you the maximum revenue? Well, the price that gave us the maximum revenue is $6. So the quantity would be Q equals 216 minus 2 times 6 squared. And 6 squared is 32, or 36, and 36 times 2 is 72, and 216 minus 72, somebody with a calculator. What is our quantity? 144. That's what I was thinking was 144. But notice it says, what is the maximum revenue? Revenue is always quantity times price, or price times quantity, doesn't matter the order that you multiply in. And our quantity is 144, and our price is $6. $864 is your maximum revenue for that product. Okay? Now remember, you're going to have a formula sheet on the next test. What you need to do is practice the derivative part of it and remember what these mean. Because that's it. We're done with 14.4. We're going to take a few minutes break, and 14.3. We're going to take a few minutes break, come back and do 15.4, because 14.4 is another derivative technique. And you have to be a little bit algebraically talented to do this one. Okay? So y'all take a break, and we will come back and do implicit differentiation. Now, hang on one second.